Hi there, I just wanted to show you how to use StatCrunch for normal distribution type problems. So I'm actually opening up the post 6364 homework that we'll be doing next week. But if you go to any question where under the Get More Help, there is the StatCrunch option here, click on that and it will open up StatCrunch. You probably want to maximize your window. And in order to be able to get the area under a normal distribution curve, the bell curve, you go to the Stat, pull down calendar like pull down menu like we've done before, and go to the calculators list item. And we've gone to binomial and Poisson back in chapter 5, but right above it, there's the normal, the word normal. So when you click on normal, up pops this normal distribution curve, and you can do problems to the left or to the right of a one boundary problem, or in between the two. The default is standard. So if we were doing, let's say, for instance, a standard normal distribution problem where the mean was 0, which is the default value, as well as the standard deviation is 1, then you could find the probability that x is less than some number. One of the very first numbers on the problem sheet asked us to find the probability that x was less than or equal to 0.44. All you do is push compute. It automatically fills the area and gives you a visual model of that area, and followed by a very precise value that might differ slightly from what you get from the tables, or if you're to use MicrosoftExcel or maybe a graphing calculator, based on not going all the way from negative infinity up to this 0.44 or some value very close to on the way to negative infinity. But either way, to the closest 10,000th for decimal accuracy, it should round to 0.6700. This is an example of when I did it in MicrosoftExcel, where I used the normal distribution function going up to 0.44, again with a mean of 0 and a standard deviation of 1. And when that is inserted and you push enter, you'll see that same area right there of 0.6700 to the closest 10,000th finds the same area. And on the graphing calculator, if I was to ask from the home screen to find the normal CDF function here with the lower bound of -1 times 10 to the 99th power, very close to negative infinity as far as our calculator is concerned, and go up to the upper bound of 0.44 with a mean of 0 and a standard deviation of 1. When I paste that to the home screen and push enter, you'll notice it also is 0.6700 to the closest 10,000th. So getting back to StatCrunch, if you wanted to do everything to the right of that boundary, you just click in this box and change it so that the probability of x is not less than or equal to 0.44, but greater than or equal to 0.44. You'll notice it shades the other area on the other side of the boundary up to positive infinity, and to the closest 10,000th, because of the 6 that comes after the 9, that would round to 0.3300, which is the complementary percent that we just computed for the area under the curve to the left of the boundary when it was less than or equal to 0.44. So you can change problems based on means and standard deviations that are different. Like, let's say, a problem involving IQ where the mean is 100 and the standard deviation is 15, and you want to find the probability that someone has an IQ greater than 111. So now when you change that to 111 and it's greater than or equal to, and you compute, again, this is a right tail area, and to the closest 10,000th, because of the 7, coming out to the 6, that would be 23.17%, rounded to the closest 100th of a percent, which is this number rounded to the closest 4 decimal accuracy. When you click on the 68, 95, 99.7 ticks, it changes the scale so that each one of these tick marks is linked to one standard deviation greater and lesser than the mean for a good visual model of comparative z-scores. If you found the z-score for 111, which is 111 minus 100 over 15, 11/15, and rounded that to the closest 100th, and then looked it up in the chart, you would find the area here that you would subtract from 1 to get this complementary area, but it should be to the closest 4 decimal accuracy the same value. Now, what about between? Let's say we are going back to a standard normal distribution problem where the mean is 0 and the standard deviation is 1. I had a problem here on the worksheet where we were finding the probability that x was between negative 0.84 and 1.284, and we had to find in here the normal distribution function to the area to the left of the right boundary 1.28 and subtract from that the area to the left of the left boundary negative 0.84, because Excel only finds the area to the left of a boundary. So to find an area between two boundaries, we must subtract the areas to the left of the two boundaries on the right first from minus the boundary to the left of the left boundary. It's nice that StatCrunch will do that for you. So if I clicked on this button here for between, now it changes the mean. The x is less than or equal to the right bound, which was 1.28 if memory serves me correctly. And I changed this as x is also simultaneously greater than or equal to negative 0.84. So when I compute that, it gives me that area of 0.6993 to the closest 10,000th, which also aligned with what Excel did to the closest 10,000th, or 4 decimal accuracy. And on the graphing calculator, if we wanted to do this, we would go to second vars, or to get to the distribution menu, and put option 2 and put a lower boundary of negative 0.84 and go up to the upper boundary of 1.28. Again, keep it as the mean is 0 and the standard deviation is 1 for a standard normal distribution. Paste that, and it will give you the same value of 0.6993 to the closest 10,000th. So moving back to StatCrunch, if I wanted to find the probability that someone has an IQ between, let's say, 91 and 113, again, let's go on the non-standard normal distribution mean value of 100 and the standard deviation of being of 15. I think I said the lower IQ of the boundary would be 91 and the upper IQ boundary was 113. This will find the probability that someone has an IQ between 91 and 113, and it gives us that area in between. And if we click the tick mark, we can see how this value correlates with the z value, not quite as negative as -1, and this 113 not quite as positive as +1. And if we were to use charts, we would have to subtract two areas to get that area of 0.5327 to the closest 10,000, because the 8 rounds the 6 up. 0.5327. So if we were to go back to Excel and try to change this problem so that it was the probability. Just ignore this. I'm just going to get rid of that old problem because it's a picture file. If I click in this cell and I want it to go from the probability that someone has an IQ from 91 up to 113, I would still compute z-scores and then compare those to the table if I did it by hand. But right in here, I'm going to put a normal distribution to the left of the upper boundary of 113, where the mean is 100 and the standard deviation is 15. And from that, subtract the normal distribution function, finding the area under the curve to the left of the left boundary of 91, again with a mean of 100 and a standard deviation of 15, and it will automatically compute that area of 0.5327 to the closest hundredth. And going back to the graphing calculator, here I would pull up the normal CDF function and put in the lower boundary of the IQ of 91 and the upper boundary of 113, change the mean to 100, and change the standard deviation to 15, paste that back on my home screen, and then when I push enter, again, it gives the same area of 0.5327 to the closest 10,000, which means about 53.27% of the population has an IQ between 91 and 113. I hope this helps.